this, and then maybe the second won't get it. You know, find ways to multiply your ability. So if you don't make it the first time, some other means will catch it. Or if you have a scoop, make the scoop wider as opposed to narrower. Make allowances for the discrepancies in the robot, because there are lots.
On the most part, just make sure that you just take a look at the field, all right? The field will give you a lot more answers than what just not looking at the field will give you. Such as, all right, so there's these lines that are going in every which direction here. Well, most of the time, when first puts black and white lines on the field, that means they want you to be able to sense it, all right? And that's also on the strategy end, but make sure that you're able to design around those aspects. Just take a look at the field, and you can see certain things, such as the mission that we did here for this year. The basic idea is that we need to capture this guy and also release this at the same time. And that's one of our design goals for that mission. And that saved us a lot of time. But how do we do it? We took a look at the field. We noticed that there's this line here, and we were able to connect the dots here.
Yep. And you can see all the sensors and everything's all designed and they're very tight, robust. We got double gears for so they don't slip. Make it solid. The more solid, the better the judges like it. Nothing worse than it falling apart in the middle of a run. Also, it splits apart and the gears start slipping, and then the robot's going in circles. So what I want to get into now is the drive system, the wheels. Small wheels, big wheels, treads. Like I was saying before, kids love treads. They're cool. It's cool to have a tank robot. Unfortunately, it's not very accurate with the sensors and the turns. So if you can steer the kids away from it, and again, the way to do that is have them build a test bot with the tracks and a test bot with wheels and see which one's more accurate. You want to go to the more accurate one. Another thing is these big squishy tires. Not very good. They slip. They tend to be different depending on the temperature. These little hard tires are pretty accurate. But then they're too small to fit beside the drive, so then you got to set up gearing. And that's a whole different aspect of gearing. If you're geared down, you're going to be very accurate, but then you may not accomplish all your missions because of the time restraint. We like to go with some medium, well, these are medium hard tires, medium size, and we got them geared down. And they seem to work pretty good. We got a caster roller. It's a hard roller. And we found that actually a couple rollers with a little bit of weight on it will help your robot go straight. You can't rely on these two wheels to drive it straight. You got to have that extra wheel. And then we have one here. We needed two, but there really wasn't room with all the parts we had. But two wheels rolling with the right amount of weight on it, it'll make you go straight as an arrow. You put a little bit too much weight forward, you have a heavy object on the front, it'll take a little weight off those back wheels, and then it's going to start wandering. And you're not going to have a consistent straight run. Also, your turns will be a little bit different. So if you have the same amount of weight on that wheel on your turn, it's going to be a consistent turn. If the weight changes through the gameplay, then that turn is going to be a little different. So the wheels are really important, and it's something you want the kids to test. And it's good for them to write down what their test, the gear ratios, the size of the wheels, and how they tested them, what they come up with, and that'll give them why they picked the wheels they did. And again, the judges love that. Anything to add to those?
Yeah, one little thing about casters. Most casters that most people know about are ones that pivot on an axis, like on a cart. Most of the time, those are actually going to throw your turns off as well. So you got to be careful about how you design casters. Such in a way, if your caster is turned and you start moving forward, your robot may turn in such but
Again,
I'll be
test it.
honest with you, I wouldn't expect it to act much differently or something.
Right, you still want something smooth.
Yes.
But it's good for the kids to test, come up with some different, try the different ones. It's just helpful to guide you in a direction, so you save some time, because you're so restrained by the amount of time you have.
So the wheel in the back does not swivel?
No, not in this.
Okay.
If you swivel it, like he's saying, it can change, especially if you go to back up or turn.
Yeah.
That little change will change how it turns.
Some people have even used kind of, it's like a rounded
Yes.
Lego piece. It's kind of skid,
Yep.
and that can touch on the ground, so it can easily smoothly move about.
Absolutely. Absolutely.
If you ever push a cart backwards and it kind of like
Right.
rolls
Yeah.
away from you, that's kind of what happens if you have this one.
Use the ball design.
Yeah, people have
If
done
you
it.
can contain the ball and ball design, that's a little more, except for then with the weight, sometimes that will also make a difference.
Yeah, we've experimented that with actually our larger robots, and it does work pretty well.
I don't know about, I'm gonna talk about attachments, and I'm gonna get back over here. Well, maybe we can do this real quick. As far as 0 point, like right there, when you put a turn into the robot, it's gonna be off just by a little bit. As you add another turn, it's gonna be off again. So if you have 3 turns, you're gonna be off 3 times the amount of the original amount. So the way to solve that is either make your missions really short, or find something at the other end that you can use as a guide. Like this one mission, we went down to the corner there, we hit the wall, we turned it back into the wall. That corner and this corner gave us a start point. So we had a new start point at this corner to begin this part of the mission. Because if we drove all the way down here and tried to do this, we'd never hit the same spot every time. So we used parts. You can run into an object. An object don't move. Like this doesn't move. You could actually bump up into this, and you know you're there every time, and then make that a new start point for your next part of the mission. You can use lines, but in order to use lines, you got to use 2 light sensors.
Actually, you can use more.
Well,
It's less
it depends on how long it is, because what happens, your angle changes. As it's zigzagging down that line, your angle changes. So if you can get down a long line and have a second one, say that you're at the cross mark, you're going to be really close to a good start point. But it's always better to have something solid to run into. That's always better. If you have a piece that's out there that you can put like a little V in the front of your or back of your robot that it just kind of slips in and sucks in there and squares up, that's a real good start point for the rest of your mission to make your next. Because you can go to use 1, maybe 2 turns are pretty accurate. Once you get into 3, the third one, and then on, it doesn't want to turn.
Yes.
Any questions so far? Okay. Arm attachments. One of our students come up with this design. This is an arm. Okay, one thing you got to watch is this one's not geared. That's a simple arm, but look, it falls down. So before your kids get into thinking, well, we'll just make a simple arm, we're done, you may want to add some gears to help hold it in place. Also, when you apply a power to it and put it in the program can move it up and actually hold it into place. The program itself will hold it there. If you want to go to a simple arm, you can. You just got to keep track of where you're at. Another thing is, when you start your mission, it's good to have your arm bottom out to a point so it starts at the same spot every time. Because if you physically move your arm and say, let's go, that arm is not going to be in the same spot. So if you have a stopper there, you have to run into it, you'll stop it. And part of programming is you don't want to use rotations to do that. So when it hits that, it's going to stop, it'll install the program out. Because the program is trying to get to that next number, it can. So what you do is you put a timer in there. Let it time up to that point, like a half a second, and then you begin your mission. Because then that arm is the exact same spot every time. And like, again, what I was talking about with the kids, what they come up with is this. Attach that to the unit, you put it in, you plug the pin into it, it's attached. A lot of teams try to put the Legos together. And I don't know if anybody's ever tried to put Legos together in a hurry. They don't go together, especially when you want them to.
That was our downfall last year.
Yep. So, pin and loop. Just slide it through, put your pin through it, holds it in there, it's solid, doesn't go nowhere, it's real easy. actually had some students come up with a spring-loaded lever. They make Lego rubber bands, and you can make a lever that you slide the thing in, you push it down, and it latches on. You let go of it, there it goes.
Here's a picture of one of the versions that kids had came up with.
Yep.
Notice how there's a rubber band right here.
Yep.
This lever is attached to this, and on this protrusion right here, there's a bar that goes across, and what this does is just latches into place.
Yep, slide it in there and latches in. And a student come up with that. So, you'd be surprised how smart your students are and what they can come up with.
And one of the funny, actually a few years ago, we guys also had such on a similar design, but what it was that we had ball mounts on our arm, so that it could be, there could be multiple positions where you can actually mount the arm on the manipulator. And I thought that was the coolest thing I've ever seen in my life.
And another thing that's good that I've seen from the judge's standpoint is a lot of teams will have, they'll pick one thing, one design, and all of their arms will implement that same attachment. So you don't have 5 different arrangements. And then that gives the people that can split up in smaller groups a design point. This is where it's going to attach. Now I know how to build it off of that unit because that's where it's attached.
Exactly. Yeah, if you come up with well, even like this, even if you gear it down and say, okay, students, this is our attachment. Make all your devices attached to this. And all they need is this to attach the thing. They slip it in and it's ready to go. Another method is design all your mission stuff on your robot. And as you do missions, you take the item off. So another mission, you take the next item off. Do the next mission, you take it off. When you're done, your robot's got nothing left, but you're done. It saves a lot of time putting parts on and grouping them together and this and that. If you can just move, the robot comes back to home, you pull the item off, and you go to the next mission. It saves a lot of time. Another thing I've seen done is where they had actually it was almost like a complete robot, but the robot would set down inside of it, and the gear from the arm would mesh with the gear on the unit. So when the motor run the mechanism inside that little mini bot, and they could just push it out and do their thing, pull back, pull a robot off, set it aside, and set another one on there. And all the motors were attached to the main part, just the gears meshed with that little attached robot. We never done that. It sounds complex, but it can be done, and it sounds pretty neat.
That was actually something I think the Japanese team.
Yeah, Japanese web.
You can only have one NXT at all.
One XT and 3 motors. So
Competition.
2 motors your drives, and it leaves you your arm. So if you can have a motor here that you can just mesh gears and it has a gear on, you just keep meshing, different parts into it. You're doing something very easy instead of unplugging the motor